So right off the bat, there's no current going into the box here. Nothing is being charged. So let's open it up. This is about a year and a half later. There's some condensation in this, a lot of it. Wow, look at that. Lots of condensation. This thing, yeah, no good. Let's check the rest of it out. There's the guts. And there's a nice little pool of water here. Let's see if we could make that out. Rusty water at that. Look at that. That's a good ounce or two there. So the battery was actually upside down when it toppled over. The electronics is wet, at least the outside of it. Okay, let's see what the voltage of the battery is. Here's my cheapo multimeter here. We'll just use this for now on because more than likely this is probably what you'll bring out there. It's light and cheap. So it's at, but like I said, I prefer the current meter here because you got more flexibility of troubleshooting with this here, my opinion. And it saved my butt quite a few times troubleshooting some vehicles with a short in it, draining the battery. And there was a slow short, or a drain rather. Alright, battery voltage is 12.06. So I got 12 volts on this guy right here still. So if you remember from last time, we used this digital battery analyzer from Medtronic. It's an older model here. So we're going to use this. And I think the reading that we had last time was between 200 and 450 Siemens of capacity of the battery here. For a more accurate reading, I have to measure the temperature of the battery itself right at the post. So this is an infrared thermal tracker, and it's 25 degrees Celsius. I have to use Celsius because that's what the machine registers. So around, let's call it 26 degrees Celsius. Okay, let's test that one more time with the correct calibration of it. Plugging in the temperature of it, which is a considerable change. .342 Siemens. One more time. 342 Siemens. So that's not bad after a year of a degraded used battery. This has been around for, I would say, 4 or 5 years already. This battery right here, gel cell, and it's been upside down all these years, all this time, in this kind of weather here, 5,000 feet, and it gets snow here in winter. So that's pretty good as far as this battery here. Okay, let's continue. Okay, one of the major problems here, these two terminals here is your battery. So our devices here are not getting charged up whatsoever. This guy here and our simplex repeater. So that's the problem there. This charge controller is toast. I think you can make out the corrosion there from moisture. The board here is was wet with moisture when I took the wrapping off. So it's got some water damage, even though I have some sort of indication here. I don't know what that LED means, but this board is toast. Up here, at least. Perhaps I could clean this off and it'll come back to life, but I'm not going to bother with it because I know it's a failure. It failed on me, eBay special, and it's not fit for long-term field operations up here for preparedness. But like I said, I brought this gear to see what substandard gear will do out in the field in real world situation, and it failed. So let's do some field troubleshooting, see if we could bring this back up in case this was a real emergency and you need this site to be up and running. We know we still have charge in the battery. We got 12 volts there. Let's see if the rest of the equipment will turn on, bypassing this charge controller, which sort of regulates the charge from the solar panels into the batteries and also controls the load of the equipment itself. Okay, upon further troubleshooting, I bypassed the charge controller. The battery and the equipment was going through the charge controller, including the solar panel, and I went directly to the battery here, to the rest of the equipment, bypassing this crap here. Nothing came on yet, and there was no current on the line there with my current meter here. So if I just check the current real quick, it's still almost nothing. And what it turned out was the fuse that connects the battery to the charge controller blew. I don't know if you can see that little black little mark there in the middle, but let's test that to see if the fuse is actually blown. So we took the offending fuse off, the suspected fuse. Now the high dollar voltmeter here, multimeter, we'll change it to ohms. And in this particular model, it'll tell you how many ohms it is of this thing here, and also give you a beep if it's a short, meaning there's no resistance. For a fuse, we want zero resistance. It's basically a piece of wire. So I go one end and then the other, nothing, and I have no reading on the numbers here, how many ohms it is. It's maximum. It's an open circuit. No current is going to go through this device here. If it was a short, where that's what we are expecting, that's what you would have heard. Now for your cheapo multimeter, it does have a ohm meter as well. So you put that at the lowest indication, 200 ohms. And if you do just a quick little short like that, it registers 1 ohm, which is pretty bad. I mean, it's supposed to be 0, but for field work, it's good enough. And it's the same thing with the same way you test the fuse out. One on one end and the other leg on the other, and there's nothing there. Maximum ohms. So you could use your cheapo multimeter out here in the field. So this fuse blew. This fuse was between the battery and the charge controller. So let's say this was a amateur, garage build, which it is, but you didn't think about fusing the hell out of your equipment here, especially out here in a wooded area where it's tinder dry. Let's say I didn't fuse this thing at all. There was a short. That means there's maximum current going from the battery into this device. If that short was not protected by a fuse, the components here could have heated up because it's getting a lot of current from the battery, and this battery produces a lot of current. I would say 30 amps at a shot. With 30 amps, this thing could get heat up and actually catch on fire. This is cheap sort of plastic fiberglass sort of material there. These components will actually heat up, catch on fire. This will catch on fire. Hopefully the steel enclosure would contain everything and starve it of oxygen, but we don't know. Perhaps it'll escape through this access hole here and catch all this stuff on fire and cause all kinds of havoc in this area here. That's what I wanted to prevent in the first place. So I got this fused. the sources of the source of power is fused at the output there. It's fused in the equipment side. It's fused here, and it's also fused where it's produced on the solar panel there. I got another 3 amp fuse there. When this equipment is transmitting, it does not produce no more than 2 amps of current. That's why I chose 3 amps to protect the equipment here. And it did its job out here in the field. But let's say you have to get this thing up and running now because things are going down at your operating area there. If it was, you know, shit hit the fan, then yeah, you do some monkey tinkering out here to get it up and running. But if it's like now where, you know, I'm just taking my leisure time here, I'm testing this equipment out, I could come up here anytime and do this. I'm going to take it down and do it right. But let's say I have to get this thing back up and running. Here's the power to the radio and the simplex repeater that's protected in this foil here. I'm going to go straight to the battery. It's still fused. I got a 3 amp fuse in this compartment right here, so I'm still protected. Go ahead and monkey that in there. I can see the radio came on, and there's GC on the display there. And I don't know if this thing came on because I don't want to unwrap it. But let's do a little op check with the radio. Here's my radio that I'm going to use on GMRS frequencies. So here we go. Testing 5, 4, 3, A, B, C, D.
Testing 5, 4, 3, A, B, C, D.
So there you have it. The radio and the simplex repeater box here from Argent Data works. So the only thing that failed was the charge controller. Since we're up here and this has took a tumble, like I said, I think a critter came up here and tossed it over because it was secure over in that area there. Let's check the antenna, see if it's still working.
Don't sweat the technique.